So welcome everybody. On today's video we'll be discussing the marginal rate of substitution, and this is the theory of consumer behavior series 3. So now we have the objectives. So first of all, I'll define the marginal rate of substitution, and secondly I'll look into the mathematical proof of the marginal rate of substitution, and also I will demonstrate numerically on how we can solve marginal rate of substitution with a question. So I'm sure, please stick around and please watch to the end. Now, first of all, find the marginal rate of substitution. Now, what is marginal rate of substitution? Now, marginal rate of substitution is the rate at which the consumer is ready to give up a certain amount of commodity X for Y while remaining at the level of satisfaction. Now, marginal rate of substitution is just simply how the consumer is ready to give up a certain amount of X, a certain amount of commodity X for Y, while having the same satisfaction along the indifference curve. You can check the previous video when I talked about the properties of the difference curve, and I made mention of the convexity of the indifference curve. That explains that well. So you can check that. About marginal rate of substitution is that marginal rate of substitution refers to the rate at which, in order for a consumer to get an additional amount of commodity X, he or she has to sacrifice a specific amount of Y while remaining at the same level of satisfaction. So marginal rate of substitution is telling us that for a particular consumer to get a certain amount of commodity X along the difference curve, he must be ready to give up a certain amount of commodity Y, and it should remain at the same level of satisfaction. I hope you get me. So now, moving on, let's look at the mathematical proof of the marginal rate of substitution. Now, as you can see, we have the marginal rate of substitution of Y and X, and it's equal to marginal utility of X over marginal utility of Y. That is a ratio of two commodities. Now, this is what we have as a marginal rate of substitution. So let's try and prove it by looking at some mathematical illustration. Now we have the proof. So we have our u which is utility, is equal to the function of x and y equals k. So k here on the equation means that while substituting x for y, it must remain at the same level of satisfaction, right? That's the meaning of what we have as k here. So moving on, we'll be applying the total differentiation in this scenario to prove what we have up here. We'll be applying the total differentiation, and when we apply the total differentiation, we have du, which is the derivative of u, equal to the partial derivative of x dx plus partial derivative of y dy, and that is partial. This is the total differentiation here. So we have the partial derivative of x from our initial function, and we have the partial derivative of y. So moving on, we can easily substitute these partial derivatives of x and y for mu of x and mu of y in these equations. We can easily substitute that for that, and that is equal to 0. We have that as equal to 0. So moving on, we can set them equal to 0 like I said in my previous slide. So when we set them equal to 0, we can easily move this mu of y dy to the other side of the equation. So when we do that, we have something like this. We have mu of x dx equal to minus mu of y dy. I hope you get me. So we can easily rearrange the function, and when we rearrange it, we have the marginal utility of x over marginal utility of y equals to minus dy dx, and this is what we have as our marginal rate of substitution in our theory of consumer behavior. This is what we have. So now let's move on by having one numerical example to make things more interesting. So now we have given that our u is equal to x raised to power 1 over 2 y raised to power 1 over 2. So this is our function, and like this we can call this a Cobb-Douglas utility function. We can call this a Cobb-Douglas utility function. So find the marginal rate of substitution. So we have to find the marginal rate of substitution given this function here. So for us to find that, first of all, we have to find our mu of x and our mu of y. So to find our mu of x, so this is the marginal rate of substitution. So we have to find the mu of x and the mu of y. So to find that, so we can also simplify what we have here as this, which is u equal to x raised to power 0.5 y raised to power 0.5. So if we can move on, we can say, so we have our mu of x equals to du dx equal to 0.5x raised to power 0.5 minus 1. So when we differentiate this x partially, when we partially differentiate this, we have 0.5 we move to the other side, then we minus we are minus 1 from 0.5, and this is what we have. So we have y raised to power 0.5. So when we partially differentiate x from this function, we have something like this. We have something like this left. I hope you get me. We have 0.5x raised to power 0.5 minus 1 y raised to power 0.5. Now we have our mu of x equal to 0.5x. When we minus 1 from 0.5, we are left to minus 0.5 y raised to power 0.5. So this is our mu of x. This is our mu of x. So now we move on. So now this is our mu of y from our previous slide. From what we have, this is our mu of y. So we have mu of y equal to du dy equal to 0.5x raised to power 0.5 y 0.5 minus 1. So we differentiated y partially and we kept x constant from the function we had on the previous slide. You can check that and confirm that. So now we can move on. So when we minus 1 from 0.5, we are left with minus 0.5. So our mu of y will be equal to 0.5x raised to power 0.5 y raised to power minus 0.5. So we still have our MRS. So we can easily slot in what we add as our mu of x and our mu of y. We can slot them inside. So when we slot them in here, so we can easily cut this 0.5. We can cut them. So we are left with this. So x raised to power 0.5 divided by x raised to power 0.5. We have x. So we have x raised to power minus 1 and y raised to power 1. So you can check that. And so this is our MRS from the question we had. From the numerical example, this is our MRS. So thank you so much for watching. You can smash the like button if you got so much value, and also please subscribe to the channel. So thank you and see you on the next video.